Okay, so let's do in class 6, number 1. We've defined the derivative of z with respect to t when t is 0, given that z is equal to the ln of x y squared. X is equal to the function of t, 2t plus 1, and y is equal to the square root of 3t plus 2. So let's first note we can write this guy as 3t plus 2 to the 1/2. Okay, so let's do two methods. First method, method 1, using chain rule. Chain rule. So by theorem 10, we have that dz dt will equal partial derivative with respect to x times dx dt plus partial derivative with respect to y dy dt. That's theorem 10. So we can figure these things out. Note that partial derivative with respect to x, so here's my f over here, so it's the derivative of the ln, so it'll be 1 over x y squared times derivative of the inside, so of the x y squared with respect to x, so the y squared. The y squareds cancel, you just get 1 over x. Fy, okay, so it's going to be 1 over xy squared times derivative of this now with respect to y, so it'll be 2xy. So it'll be cross off an x, cross off a factor of y, it's like 2 over y. Okay, dx dt. So my x is equal to 2t plus 1, so derivative with respect to t would just be 2. And dy dt okay, here's my y here, so I use the chain rule. So take the 1/2 in front, math 150 chain rule. So the 1/2 in front, 3t plus 2 for the 1/2 minus 1 times derivative of the inside, which would be 3. So we could write this as 3/2 times 3t plus 2 to the minus 1/2. Okay, so then in place of fx up here, we can substitute 1 over x. In place of fy, we can replace with the 2 over y. In place of dy dx, we can put 2. And in place of dy dt, we can put this guy. So making those substitutions, let's call it star. This whole thing. So I'm going to sub into star. Make this now. So sub into star. We get dz dt. So it's fx, which is the 1 over x, times dx dt, which is 2, plus fy, which is a 3/2, times 3t. Sorry, it's dy dt. Second. So the fy is 2 over y, sorry. 2 over y times the dy dt, which is the 3/2, times 3t plus 2 to the negative 1/2. Okay, so let's see, we can cross off the 2's here. So recall that our x was equal to 2t plus 1 and y is equal to 3t plus 2 to the 1/2. So when t is equal to 0, we have, so the x is 0, be 2 times 0 plus 1, so x will be, let me just say x. You can say x is 0 if you want. You say x. So x will be equal to 1 when t is 0, and y will be equal to 3 times 0 plus 2 to the minus 1/2, which is 2 to the minus 1/2. Okay, so we're going to substitute that into this guy up here. So in place of x, I'll put 1. In place of y, I'll put 2 to the minus 1/2. And in place of t, I'll put 0. So then we'll have dz dt will be 1 over x, so it'll be 1 over 1 times 2 plus, 3 over 2 to the minus 1/2 times, putting 0 here, 2 to the minus 1/2. Okay. Actually, sorry, I just caught something. Sorry, the y doesn't have a minus 1/2 here. So take that back. So it's actually positive 1/2 here. Yeah, I plugged in the document wrong. Should have been 1/2. Okay, so we get that. So let's simplify this. So then 2 plus 3. You can write this as square root of 2. Now 2 to the minus 1/2, you can write as 1 over square root of 2. Multiplying those, we get then 2 plus 3 over 2. Then 2 you can write as 4 over 2. So it'll be 7 over 2 is our answer. So that's the answer we get from method 1. Let's do method 2 now. Okay, so now let's do method 2. Method 2 will be without chain rule. So we're going to write z as a function of t. So note, z is equal to ln of x, y squared, x equal to 2t plus 1, and y equal to 3t plus 2 to the 1/2. So we're going to make the substitutions to write z as a function of t. So put that there, put that there. Implies, so z as a function of t can be written as ln of 2t plus 1 times 3t plus 2 to the 1/2 squared. Okay, so this we can simplify a bit as ln of 2t plus 1. Squaring this guy down does it, so it's be times 3t plus 2. And now to make things a bit easier, I'm going to recall I guess here. Oh, yeah, recall here. Oh, just out right here. So using properties of log, essentially multiplying two things here. you can break this up as a sum, so the ln of 2t plus 1 plus ln of 3t plus 2. Okay, so recall the rest over here. What I'm using is if the ln of a times b, that equals the ln of a plus the ln of b. Okay, so let's keep going now. So now I'm going to take the derivative on both sides. Do that. Okay, so taking derivative, so let me write my z up here again. So z we have is ln of 2t plus 1 plus ln of 3t plus 2. So taking derivative of z with respect to t, so dz dt, so it'll be 1 over this. So 1 over that, times derivative of 2t plus 1 with respect to t, so be times 2. Plus, moving on to the next one, 1 over this, t plus 2 times derivative of 3t plus 2 with respect to t, which would be 3. Okay, so we get then dz dt equals 2 over 2t plus 1 plus 3 over 3t plus 1. So that's our derivative. So now let's evaluate when t is 0. So when t is 0, we have dz dt equals 2 over 2 times 0 plus 1 plus 3 over 3 times 0 plus 2. So we have 2 plus 3 halves. Again, write the 2 as 4 over 2 plus 3 halves. So 7 halves, which is the same as the answer for method 1, as it should be. So we're done.